All right, in this video, we're going to go over solving inequalities. All right, we only have one vocab word today, which is compound inequality. A compound inequality is two inequalities joined with the words and, or. So, and, or. All right? So, what we need to look at first here, writing and graphing inequalities. All right, so if you see x is greater than 4, here's the symbol. In a sentence, it would say x is greater than 4. And then to graph that, if you notice right here, there's an open circle. It actually that might be hard to see. What it looks like is this. You have your number line, you have 4, there is an open circle, and then it is shaded to the greater than side with the arrow. All right, so anytime you don't see an equal bar, you are going to have an open circle. All right, you're going to have an open circle. So here is x is greater than or equal to 4. Words. What the only difference in the graphing is this is a closed circle or a dot. Then you have x is less than 4. X is less than 4. Again, here you have the open circle. And then less than or equal to 4, again you have a dot. All right, that'll be a dot. And that'll be open. All right, so just a few things you need to know when you're graphing. An open circle means it's not included. So open circle means not included. And a dot, or a closed circle or filled in circle, means included. So this here is greater than 4, so if it equals 4, you can't include the 4. All right, that's why you have the open circle, because you can't include the 4. You can get close to the 4, but you can't include the 4. All right. Transitive property. So properties of inequalities, they have the same properties like equations do. So they have transitive. If A is greater than B and B is greater than C, then A is greater than C. Quick example, 5 greater than 3, 3 is greater than 1, so 5 is greater than 1. Addition property, if A is greater than B, then A plus C is greater than B plus C. So if 4 is greater than 2, 4 plus 1 is greater than 2 plus 1. And then the subtraction is the same way. If A is greater than B, then A minus C is greater than B minus C. Multiplication, if A is greater than B and C is greater than 0, then AC is greater than BC. So 6 is greater than 5, 3 is greater than 0, so 6 times 3 is greater than 5 times 3. If A is greater than B and C is less than 0, then A times C is less than B times C. So 3 is greater than 2, but negative 4 is less than 0, so 3 times negative 4 is less than 2 times negative 4. And division, if A is greater than B and C is greater than 0, then A divided by C is greater than B divided by C. So 9 is greater than 3, 3 is greater than 0, so 9 over 3 is greater than 3 over 3, because this is 3 and that is 1. And then if A is greater than B and C is greater than 0, then A over C is less than B over C. So if 12 is greater than 6 and negative 6 is less than 0, so 12 over negative 6 is less than 6 over negative 6, because this would be negative 2, whereas this would be negative 1, and negative 1 is greater than negative 2. All right, so make sure you have these properties written down as well. You're going to need to refer back to them. All right, taking a sentence and representing it as an inequality. You need to look for a few things. You need to look for the key words. Here it says fewer. So fewer means less than. Oops. T-H-A-N. All right, so 5 fewer. Fewer means less than. And then we have at least 12. Okay, 5 fewer than a number is at least 12. Okay, so that at least indicates greater than or equal to. Actually, this isn't. I'm sorry, I did this wrong. Fewer indicates subtraction. Sorry about that. I don't know why I said that. And then at least 12 means greater than, if I can't spell today, or equal to. All right. So 5 fewer than a number. So we know that 5 fewer than a number will be x minus 5, or whatever variable you want, because that's 5 fewer than a number, is at least 12. We know the term at least means greater than or equal to 12. All right. So let's look at another one. It says the quotient of a number and 3 is no more than 15. All right, we need to turn that into an inequality. So, how do we do this? Well, we know that the quotient of a number and 3, we know quotient is division. So the quotient of a number in 3, the number we can use is x, and so the number in 3 would be x over 3. We know that is no more than 15. Okay? No more than. Okay? No more than is less than or equal to. All right, we know this is no more than 15, so we know it is less than or equal to 15. So there we go, less than or equal to 15. So at least is greater than or equal to, no more than is less than or equal to. And of course, fewer is subtraction, quotient is division, product is multiplication, and difference, well, and you know, like 5 more than a number, that would be addition. All right. So let's look at solving an inequality, and then we're going to graph one, this same one. So what is the solution to negative 3 times 2x minus 5 plus 1 greater than or equal to 4? First thing I would do, distribute that through. So negative 6x minus 5 plus 1 is greater than or equal to 4. All right. Oops, 15. Negative 6. Wow, I messed it all up. Negative 6x plus 15 plus 1 equals 4. Okay, we distributed it through. So now this is negative 6x. This comes out to plus 16. That is greater than or equal to 4. Subtract the 16. Negative 6x is greater than or equal to negative 12. Divide negative 6. Divide negative 6. So x is less than or equal to 2. Now if you notice here, I divided by a negative across my inequality sign. When you divide or multiply a negative number across your inequality sign, you have to change its direction. Don't forget that. All right, when you multiply or divide a negative number across the inequality, you have to change its direction. You keep the equal to bar if it's there, but you have to change the direction of the inequality sign. All right? So this is our solution. You solve it much like an equation. The only difference is, like I said, being multiplying or dividing negatives, you have to flip your sign the other direction. All right, now how are we going to graph this on a number line? Well, here we have a number line. 0, 1, 2, 3, negative 1, negative 2. Okay? So we know x is less than or equal to 2. All right, so we're going to go to 2. And since we have the equal bar, we're going to put a dot, a filled in dot, because we're including the 2. And since x is less than, we're going to shade everything this way and then put an arrow on the end of it. So everything less than negative 2 will solve this inequality here. Okay? If you notice, this inequality kind of points the way that you're going to graph. As long as your x is on the left, you can kind of make an arrow out of this. So that points to the left, you're going to shade everything to the left. If x had been greater than or equal to 2, again, you can put your arrow, so greater than or equal to 2, we would have shaded everything this way. So as long as your variable is isolated on the left-hand side, you can make an arrow out of your inequality sign, and that'll show you which way to graph, or which way to shade. Okay? Now, compound inequalities joined by and, or. Here's what one of those looks like. It says, what is the solution of 7 is less than 2x plus 1 and 3x is less than or equal to 18? All right, and then we're going to graph the solution. So, what we're going to do here is we're going to solve each side like it's its own equation. Own inequality. We're going to kind of ignore that it's a compound one for right now. So we have 7 is less than 2x plus 1. Subtract the 1, 6 is less than 2x. Divide the 2. So 3 is less than x. Now we can flip this around to say x is greater than 3. Okay, this is the same thing. I didn't change anything. I just moved the x to this side and the 3 to this side. And since I did that, also I had to flip the inequality sign around. So now let's do this one. 3x less than or equal to 18. Divide 3, divide 3. 18 divided by 3 is 6. So x is less than or equal to 6, and x is greater than 3. So let's graph this. All right, so x is greater than 3. X is greater than 3 looks like this. We have a dot at 3, and we fill in everything this way. Okay? Now, x is less than or equal to 6 looks like this. You put a dot here. I hope this turns out like I want it. No, that's just going to turn out nasty. You put the dot at 6, and you shade everything this way. All right. Now, everything in between them is what solves the inequality. And did y'all catch that I put a dot here? There's no equal to. This should be a circle at 3, not a dot. All right. And now, everything in this section that I wished would have turned purple. So everything in this section is going to solve this compound inequality. All right? And you can actually write this: 3 is less than x, which is less than or equal to 6. That would be how you write this, because x has to be greater than 3, but less than or equal to 6. So x is greater than 3 and less than or equal to 6. All right? So for solving compound inequalities, you basically solve them individually, graph them, and then figure out where they overlap. If they don't overlap, then of course you can't write it like this. You just have to leave it in these two forms. Okay? And here's an example of that. It says, what is the solution to 7 plus k is greater than 6, or 8 plus k is less than 3? So again, solve them individually. So k is greater than or equal to -1. And then 8 plus k is less than 3, minus 8. K is less than -5. So draw a number line. -1, -2, -3, -4, -5, -6, -7. So k is greater than or equal to -1. So -1. Since the variable is on the left side, we can kind of make an error out of that. So we're going to shade everything this way. Make a nice dot there. And then k is less than -5. So open circle at -5 because there's no equal to bar. And then again, your variable's on the left, so you can kind of draw your arrow. Everything this way will get shaded. All right, so now this is your graphed solution to this equation. So the OR means that these solutions makes either one of these true. All right. Now the values from this one might not necessarily make this one true, but it'll make this one true, and that's what the OR means, either this or this. All right. So that's been your Solving Inequalities video. Make sure you understand it and come to class tomorrow ready to work some problems. See you tomorrow.